Thank you. We are the MSU Denver team, and as you can see, the title of our project is Plotting the Platte, Measuring Vernal Change Over Multiple Seasons Using Landsat Imagery. Next slide, please. Our team members are Eddie Wolf, Reese Donovan, Jennifer Kearns, Ken Doyle, and Dominic Gardner, with advising from Dr. David Parr and Dr. Gabrielle Katz. Unfortunately, Dominic couldn't be with us today for personal reasons. Next slide, please. Some background for our project. Phenology is the study of nature's changes throughout the year. It can answer questions like, when do flowers bloom? When do particular animals mate or migrate? Many aspects of our survival, such as water and food availability, are dependent upon reliable cycles of nature. In Colorado, millions of residents rely on the flow of the South Platte River. Phenological changes could impact the availability of that water, its quality, the stability of the riverbanks, the health of the flora, and the ability of wildlife to survive and thrive. The agriculture industry is particularly reliant upon understanding and maintaining the health of the South Platte River, as there are many, many farms found in the rural areas along the river. Identifying phenological trends, especially in combination with water analyses, can help to inform conservation, agriculture, and development plans and policy, which in turn have a direct effect on those relying on the river. Next slide, please. So before we cover our project, here are some terms to know. Riparian zone, the interface between land and a river or stream, derived from the Latin term ripa, meaning riverbank. NDVI, which is Normalized Difference Vegetation Index. This is an indicator that describes the greenness or relative density and health of vegetation for each pixel in a satellite image. The values range from -1 to +1. And SOS, start of greening season. This indicates the time starting the maximum increase in vegetation index during the green up season. Next slide.
Okay, so our study area obviously is the South Platte River Spring, which springs from the Mosquito Range in South Park, Colorado, and it runs about 450 miles across northeast Colorado. The South Platte River watershed is about 62,937 kilometers or 24,300 miles, and it with approximately 25% of that occurring in the South Rocky Mountains and 75% of that occurring in the Great Plains area. The South Platte River is also the primary water source for the Metro Denver area, as well as for agricultural uses in northeast Colorado or northeastern Colorado. So prior to the, next slide, please. Thank you. Prior to the 1960s, there was little to no vegetation along the river in the riparian zone. After the 1960s, as settlers started to move into the area, water development began as an essential part, which essentially changed the behavior of the river and then changed the behavior of the vegetation as it began to grow in the riparian zone. There have also been noticeable differences between widening and narrowing of the river, which affects the amount of the riparian zone. And that is important because as of today, about 90% of the vegetation in the riparian area is cottonwoods. And the cottonwoods are known to be prolific water users. And that eventually creates tensions between the ecosystem benefits and services of the forest that the forest provides, and then the water usage itself. This can lead to tensions. Excuse me. So eventually this leads to tensions between humans' needs for water and, of course, the vegetation's needs for water. The concern is that with urban populations rapidly increasing, which obviously increases the demand for more water, and the threats of global warming, a struggle will occur for the resources between us, especially if vegetation such as cottonwoods persist along the riparian zone. So now you can imagine the same scenario that happens in every riparian zone across the globe, which will ultimately lead to a precarious situation. So this leads to the question, If the growing of the seasons are getting longer, then all of the vegetation in turn will use more water. The increase in water usage by vegetation may accelerate greening, which is greening of the leaves, which is the signal for spring. Next slide.
Hi, I'm Ken Doyle. I'm going to give you a brief overview of our methods. First, we had to find and download the data. We used Earth Explorer, which is a free online utility hosted by USGS, and we searched for Landsat imagery of our study sites along the South Platte River. And based on the climate in the area, we assumed that the start of the growing season would begin sometime between February 15 and May 15th. So we limited our search criteria to only include those scans within that time period. Once we obtained the data, we then plotted and uploaded and plotted the red and near infrared imagery bands to visually inspect for any scan line areas or cloud cover within the scans that might yield some inaccurate results. After plotting and identifying the scans with excess cloud cover, we cleaned up the imagery by removing those pixels with insufficient data or scan errors. Then once our data was cleaned and ready for analysis, we utilized raster statistics to obtain the mean and maximum NDVI values for each of our study sites for within each time period, and then created individual data tables to plot our results. We then compiled the data tables from each time period, plotted the mean and maximum NDVI values, and then analyzed the plots for any observable trends that might indicate a shift in the start of the growing season over time. Next.
All right, this is Eddie speaking. So as far as the results, we were only able to identify values within 2 of the zones, which are pictured here on the left in the color infrared plot. As far as the right, we've got a statistic max, mean, and the median NDVI values for both of those zones of the South Platte River. And again, we were looking at the months of February through May, and we were able to look at values for the time periods of 2000, 2005, and 2015. I also wanted to mention the count column, which is basically the pixel count, which signifies the size extent of each riparian zone. And we were looking at imagery which had a 30-meter resolution. Next slide, please. So the 2 plots on the left are going to be the max NDVI values for both of those riparian zones. They're going to be for the years of 2000 and 2005. So we were basically looking at the highest max greenness value, which would be related to an NDVI value of greater than 0.6. That measurement is going to be reflective of the start of the spring growing season. Obviously, you can see that there are similar values occurring between both zones. And you can somewhat see that there are max NDVI values which tend to increase in the later months, which would be early May. You may notice some large dips in values, which are going to be related to some persistent cloud and snow cover in some of the imagery tiles. Next slide, please. This is going to be a plot of the most recent date range that we were able to look at. It's going to be the max NDVI value for both riparian zones for the year of 2015. Overall, you can somewhat see that the highest max greenness value seems to accelerate in early April for the later years, as opposed to early May for the earlier years. There were obviously some outliers that made it somewhat difficult to establish this type of certainty, but hopefully with more data, we'll be able to reveal some stronger greenness trends. And I think in hindsight, we feel that if we would have started the analysis at a later date and would have gone into the early summer months, this may have been beneficial in establishing a stronger greenness trend. Next slide, please.
Our research methods could be replicated to include the arrival of autumn over this 20-year span, which would give insights into changes in annual growing seasons. This research could be a great complement to ongoing water research along this region of the Platte River, resulting in a better understanding of what is influencing any notable trends. And in turn, this will help to inform development and resource planning. Thank you.